Hi, everyone. Welcome to Synteda Group's webinar regarding about integrating large language models with advanced tools to solve complex tasks. We're going to have a seminar with Dr. Diogo Buarque who's he has a doctorate in physics, and he's going to talk about how to find LLMs in ChatGPT, which shows proficiency on various NLPs, natural language processes. In generating plans, you can find it in writing source code, interpreting the results, as well as solve complex problems. So we are part of Synteda Group, and we usually have these webinars one per month, and we have done it for the last 2 years. You can find us on LinkedIn, also on YouTube, on the social media, and of course on our website, synteda.se. We are based here in Gothenburg, Sweden, and we are very happy to have Diogo having this webinar with us today.
So thanks for the introduction. So you already know my name. I'm Diogo Buarque. I'm going to talk about integrating large language models with some advanced tools and libraries to solve complex tasks. So let me start now with some introductory slides. Okay, so let me start with this nice evolutionary tree of large language models. You can see that these models started about 5 years ago, these large language models, and is already causing a big revolution in society and in the industry. There are two milestones in this tree, which are ChatGPT, which gives a very important, very powerful way to communicate with machines in a natural and efficient way, with broad impact in society. So there was a boom with a lot of people using in all industries, in education, healthcare, law, journalism, and etc. And as you can see, most of the big companies, at least, they are heavily investing in training large language models. So you can see Google, Meta, Microsoft, and OpenAI. So I saw recently the USA Senate passed a bill to form an AI task. I think was driven by this. So this was a news I saw recently, and it reminded me that so today is May the 4th, and so I did my introductory slides in homage of Star Wars. This is today is the day of Star Wars, May the 4th. So this is the Senate. You can imagine that they might be discussing the use of droids, maybe something like that. So now, in this perspective, I would call ChatGPT a Padawan. So it has the force. So it's a very powerful tool, but it's still doing a lot of mistakes and stupid things. So, but it's a revolutionary tool, and it what caused the boost in the use of large language models. So in the original paper, they used the GPT-3 as a base model and the reinforcement learning using human feedback. So it became the most powerful chatbot in AI history. So it's like you can talk with it. It's a sibling model to instruct GPT, but it's optimized for dialogue. And everybody here probably have already tried it, how impressive it is. And you can imagine just in less than 1 year, all the applications and impact in distinct areas, such as business in business and industry, like education, science, technology, government, politics, healthcare, medicine, infrastructure, law, IT, and etc. So in less than 1 year, there are 700, almost 750 citations in semantic school. So if ChatGPT is a Padawan doing a lot of mistakes, another milestone in large language model came with GPT-4, which I would say it's like more like a Jedi Master. So it's a multimodal. It has multimodal signal, so it accepts image and text, and it also has much better structure in solving more complicated problems, and exhibit superhuman level performance in some tasks and in various professional academic benchmarks. So in 1 month, there were 82 citations according to Semantic School. So you see here how it outperforms ChatGPT in several of these exams. It has impressive results in all these exams. And you can just notice these area here where these models does not perform so good. This is math, AMC, and calculus. So ChatGPT can't do much with math, but then GPT-4 can get a big boost, big improvement on that. So now, even a Jedi must know how to control the Force, as you know, otherwise you can go to the dark side of the Force. So even GPT-4 has a lot of limitations. So some of them are lack of current word knowledge, difficult with symbolic operations, difficult with rule-based tasks, arithmetic mistakes, counting errors, lack of common sense, and also ethical and societal concerns like job displacement, political manipulation, plagiarism, etc., which must be tackled in a organized way with society. So here I give some examples of GPT limitations related to knowledge recency. So like if you ask what's the president of the United States now, it can't give you the right answer because it's trained only with the old data. Also, if you ask mathematical operation with large numbers, you typically get some wrong answers. And another example is counting characters, or there are a lot of other examples using very simple rule-based tasks that humans can do very well, but GPT-4 can't. So there are two options towards improving this kind of framework. I want to call it master Sith model. It's like just one single multimodal trained with text, image, videos, or physics knowledge, common sense, etc. This is one way. And the other way, which is the short-term way that we're experiencing now, is more like a Jedi Council model, where we integrate large language model with several other models, tools, library, etc. So this talk, I will concentrate on this kind of direction of improving large language models, how to integrate it with other tools, and in order to achieve larger goals. So an example with GPT-4 with a tool-augmented GPT. So, for instance, is trained to use calculator, search, and character counting to solve the limitation that I just showed before. For instance, if you instruct GPT-4 to use some of the tools like search and calc and character, you can GPT will understand that and will call these APIs to give the correct answer. For instance, if you ask the President of the United States, it will use search tool and it will give you the right answer. And the same way, if you ask some math calculation, it will give you the right answer. It will call an external API and compute and give you the right answer. So that's it from my introductory slides. So we won't see any more Star Wars. So now since this is the first talk of, that I hope to be a series that we're going to discuss with the group that we started yesterday, I found that would be interesting to start with a review. So a brief review of large language models. I think that would be useful at least to go through some basic concepts and create a base knowledge of what we need to do, what we need to know fundamentally to understand more complicated features, let's say. And then the second part, I will discuss more specific integrations, and then I will give some remarks in conclusion. So let's start with the review. So of course, as I said, I'm not an expert, and there are several reviews and talks by experts that are already available on the net. So I will base this talk, this section on this paper here, a survey of large language models. It's misspelled here, sorry. So the first point is that a language model is a probability distribution over a sequence of words. So it's basically have some words and you know what's the probability of finding the next word. Modern LLMs consist of a deep neural network of hundreds of billions of weights, which are pre-trained on a large amount of text, web pages, conversation, book, multilingual codes. So in this table here, you can see all the available LLMs. Can you remove these? Okay, so here you can see some public available tools and closed source tools like GPT-3, GPT-4, ChatGPT. Here's the size. So you see typically, for instance, GPT-3, you have 175 billion parameters. So these are the weights of the deep neural network. And you can see also, my arrow's not, okay. You can see also the amount of tokens used, so the data used. GPT-3, for instance, is 300 billion tokens. Which this is the data where it is trained at. And some of the models see that it's based on a model, so it's called base model. So this means, for instance, ChatGPT uses GPT-3 as a model, and then fine-tune it to some specific tasks. We'll talk a bit more about fine-tuning, not in detail, but it's how it is. Okay, so now data is, there is a process to pre-process the data, passing through quality filtering, deduplication, privacy reduction, and tokenization. So tokenization is basically transforming all the words into a set of more or less, in case of GPT-3, 50,000 tokens. These are basically the common words, the letters in the alphabet, and some pieces of words mostly used a lot. And these are the corpora of data taken. Some of the corpora that are used by LLMs, Wikipedia, books, and etc. So once this data is prepared, it goes through some kind of deep neural network architecture based on transformer. This is a very important concept and a very important architecture for large language model. So sorry, let me just. So the transformer was proposed in this very important paper called "Attention is all we need, all you need." After that, there has been a lot of other papers saying transform is not all we need, and a lot of other titles using all you need. So it's important in particular because it's appropriate for parallelization. There is no need for recurrent neural network. and they are a kind of generative artificial intelligence specialized in text-to-text. But also to, as you noted that in other multimodal, you can also do generative AI for images or different things. You also using transformer, but originally it was text-to-text for translation specifically. So there are two main derived technology. One is the vanilla transformer, which is what is in this original paper called encoder-decoder. And then there is also called causal decoder, or also called only decoder, which is what's used in the GPT series. So I'll just try to very briefly explain a bit what it is in the transformer. Unfortunately, my prompt is not appearing very responsive, but okay. So the idea is now that the input here is a embedding. Embedding is basically a low-dimensional vector representation from a corpus of text, which preserve the contextual similarity of words. So in a representation, so-called one-hot representation, you basically have for, like, let's say 50,000 words, tokens that you have, you can represent with a vector of like 0, 1, depending on the, or like if word cat is related to the second in this vector, then this representation would be 0, 1, 0, 0, 0. But in case of embedding, you lower this dimension, and you also relate some words in a vector with more information about these words. Then you also put some other kind of embed called positional embed that is related to the position of this word in the what you give as input. Then these embeddings go through the encoder. In this case here, the encoder is this block here. So it goes through a multi-head with multi-head attention, and then go to feed forward. A deep neural network is also called multi-layer perceptron. And then in this case of encoder-decoder, you see this NX here. My pointer is not NX, so there is a lot of these encoder stacked over each other. And then these will go after the output will go to the decoder. For instance, that will give you the output of what you give. And the decoder has a very similar architecture, but you can notice that there is this masked multi-head attention. The masked basically means that every token that it goes after will be masked, so it will not take into account stuff. Tokens that goes after so it will look both at the input and the output, but only the stuff that goes previously to what is going on. So for instance, when you see ChatGPT, it's writing something, you never see it's changing the words that it's already written. So this is basically what the mask does. It does not use the stuff that goes after to predict your next word. And then what's also important at the end of everything, it will also pass through a stack of decoder. And then after everything, it will go to another deep neural network, a linear neural network, and go to a softmax function that basically transform into a probability of all the words. So in this case, it will go to the full size of the vocabulary that will give probabilities of the words. So you get at the end the probability of the word that you want to see, and that's what you see when you code something in ChatGPT. So another important concept is this self-attention that's in the core of these models. And I just very briefly say what maybe it's a bit technical, but I think it's important to at least know what the concept is and know where to find more and to understand it better. But it's a attention mechanism relating different position of a single sequence in order to compute a representation of the sequence, basically. So you basically, after putting the embedding, so here's an example. You give as input thinking machines, and they will expect something as output. So these will, each of these words or token will have an embedding, and this embedding will be multiplied by a lot of matrices of weights called the queries weights, the keys, and the values. So there will first be a score of the query with the keys. So that will be that will basically give a proximity. So when you do, if you know some math, if you do a scalar product, it's basically a measure of the distance of proximity of different vectors. So this will give the proximity of the different words. So that's what the attention gives you. And then this will be projected into these values, these V's, to get a final internal representation, abstract representation. So for each word, for each token, this will be giving you a specific representation, and then they can be done in parallel. So, but I know it's a bit too technical, but just you can have an idea. And it's interesting also if you try to see Whisper, what is one of the OpenAI tools, you can see where it's putting the attention you can see the word, and it's seeing where it's putting the attention. So it's basically this: what are the relation of what of each word, where it's giving attention, and this is what to be related to the next word. So now typically you have this multi-head attention. So it's a lot of these head layers that will be multiplied and produce a huge number. All these weights are pre-trained, so they are already once you use it, it's already a lot of weights that are already pre-trained and are fixed. So you take your embedding, multiply by these weights, getting the query, the key, and the value matrices, and the output that will finally go through another matrix. All these weights are trained during the model, even including the embedding. The embedding also is trained during the process of training. So then this output goes to the next encoder or decoder. So you go through, you go in stacked layers. So if you want to see more detail, you can go to these. I found this page that is very interesting and very pedagogical explanation. Okay, so now the last part of that is important to understand is the training. So if you put these words, this input, like let's say thinking machines, into a model that's not trained, it will just give you some random output, right? So what happens is that you have to put that into into the machine, to this transformer, and use stochastic gradient. In reality, is some version of stochastic gradient. You typically add them to do a self-supervised training of the model. So basically, the weights are updated to minimize a loss function, usually cross entropy. So what that means is that you have a target model. The target model is basically what you find in the text. You have a lot of text, and for instance, you see translations, text translating English to French, for instance. Sorry, French to English, let's say. So you see that you have a lot of text that say the input will be "Je suis étudiant" and "Je suis étudiant" and the output will be "I am a student." So here is the target model, is what you find in your data that you are using to train, and this is what you get, and then you get something from the model. It will start with random numbers here, but once you start adjusting the weights, you get something like that, which is the training model output, which gives you the correct position and correct words in this model. This is, of course, is a very simplified model with just 6 tokens, and then you get the correct values. So just a curiosity and interesting information that GPT-4 estimated the training cost of $200 million using 10,000 this processor, I don't know, for 11 months. So it's a very, very consuming process. Very expensive. Let me not go into much here, so GPT-4 is still another class of models. It's called multimodal language process. It processes both text and images. So if you see the corpora, it has a text corpora, but also image caption pairs and interleaved text and images. So it gives some further complication that you have to include images. You have to use a common embedding for text and images, and this brings some complications. So if you want to see more details, you can check this web page. There's some explanation. So the model, large language model, the name large in large language model, there is not really any conceptual, any difference in the terms of the architecture, but it brings some qualitative difference with respect to smaller language models. That's why they start calling it large language model. So these are these emergent abilities starting from large language models. In particular, in context learning, which is the fact that they can accomplish some tasks even if they are not trained for, just giving a few demonstrations. These were not observed in smaller language models. They can do instruction following, step-by-step reasoning. And then people start developing some techniques to use it, these large language models, which are also important when we discuss integration with the other models. So the main techniques is prompt engineering and ability listing. So these are chain of thought prompting, instruction tuning, alignment tuning. So for instance, if you see large language models are likely to generate toxic, biased, or even harmful content for humans. So if you just take, for instance, GPT-3, it will get all sorts of output. So what they do is they use alignment to human values. For example, ChatGPT uses reinforcement learning using human feedback, and that will that's what the tuning and alignment of the model into something that's more useful to humans, and that's what makes it more like a conversation app. And then there is this concept of fine tuning, which is training the model further on a smaller target data set that's relevant to the desired task or subject matter. And then also to manipulation. So just some, this is my last slide on this section, I think. And it is just some important concepts on prompt engineering that you see all the paper, everywhere you see all APIs and papers, you see these concepts. So it's good to know it. So the first concept is zero and few shot prompting, and it's part of in-context learning. So zero shot is basically asking a question directly, like what's the square root of 9? And then few shots, like one shot, is that is the technique that you give an example, and then you expect the output. So it helps a lot the machine to understand what is expected. For instance, in this case here, it gives an example of what is expecting. So it says, what poo is a small furry animal native to Tanzania. An example of a sentence that uses the word what poo is, we were traveling in Africa and we saw these very cute what poos. And then he goes on, and to do a fart pull means to jump up and down really fast. An example of a sentence that uses the word fart do is, and then the ChatGPT will give you an answer that is guided by your example. So it says, when we won the game, we all started the fart do in celebration. it helps the machine to understand it. So this would be a one-shot prompt. Another technique in prompt engineering is an important technique is chain of thought. Sometimes COT. And when you do the one prompt or one shot or few shot prompt, what you do instead of you do the example. When you do the example, for instance, in this case, Roger has 5 tennis balls. He buys 2 more cans of tennis ball. Each can have 3 tennis balls. How many tennis balls does he have now? The answer is 11. So it gives directly the answer, and then ask the question to ChatGPT, and he'll give you, and then he couldn't think this mathematical problem, he gives you a wrong answer. But when you use chain of thought prompting, instead of just giving directly the answer, you explain the machine how it will reach the result. So it will give some step-by-step reasoning to the machine. So like in this case, like it says, Roger start with 5 balls, 2 cans of 3 tennis balls each, and 6 tennis balls. So 5 plus 6 equals 11. The answer is 11. So it gives some guidance to the machine to how to think about this kind of the kind of problem that he was going to get the output. And then it gives the correct answer because it also uses this kind of idea of going step by step. So this is an also very nice emergent ability of large language models. Then there are other techniques. I will skip them, but you can have a look later. I also mentioned this web page here that has some guidance for prompt engineering. It's very, very useful. So this is my last slide in the introduction, in the review. So it struggles with controllable generation, so it can handle local planning very well, but might struggle with global planning. What that means? So that means that if you, for instance, if you want to write a game, if you just ask, write me a game in Python, it will not be, but you can write step by step, part by block, and then you can get, but you have to guide him. So you cannot do like very, very global and large projects. It also struggles with more specialized generation that will require some fine tuning. That's why a lot of papers, a lot of work has done, including some fine tuning, some extra information to the model. It also has a problem of hallucination. Sometimes it gives completely wrong results, but it's very convincing, saying, and even if you ask back and it will reply, no, and try to convince you that he was correct. It has the problem of knowledge recency. Because it's trained from old data, not with recent data. A lot of problems with numerical computation, knowledge, symbolic and mathematical reasoning, and lack of common sense. So things that for us is very simple, because these are trained on just text. They don't have the special feelings and the way that humans know. So they lack some very simple common sense ideas. Even though GPT-4 had a much better than ChatGPT, but still lacks common sense. Okay, that's the end of my first part. So now for the integration. So my idea here was I took some papers citing GPT-4 report, and I select some that uses some tools, and I will just mention them quickly. Of course, each of these papers require a whole talk just to explain. So I didn't read all of them, of course, and I will just put there, and you can have some ideas of what's going on and what can be done with these tools of integrating LLMs with other APIs or something else. So let me start again mentioning the idea of, as I mentioned, this like the Jedi Council model. So it's like you have a LLM as a component on a modularized brain that serves as a middleware to connect other generative models, tools, and libraries. So this is more or less like our brain works. So there are a lot of each part will have some kind of specialization, modularization to solve different things, and they are connected. So there are I divide these in two classes. One is tool augmentation, so basically calling APIs that already exist, search engines, calculators, calendar, and things like that. And the other is more like writing and running code. So you have just to put a compiler integration in the model, and it will write a code from scratch and solve whatever you need. These are the two classes. So first, let's start with tool augmented LLM. This is already established. In particular, I think the first model was this the first paper was this two form, and is a way that to include tools inside the language model. So it's a model trained to decide which API to call, when to call it, the arguments that it will use, and then incorporate it into the token prediction. So the example that I gave at the beginning, I don't know if you remember, it says if you need some calculation, call this app, call calc. So when you ask some complicated question, then it knows that we'll need some calculation, and then you see in the prompt output, it will give calc. So that's the way that it works. So you explain the model, how what you require, and then it will call the API directly. And then it's impressive. So they mentioned that it's in this paper that it's impressive how with just a few shots prompting, it managed to understand what API it's needed. So GPT-4, for example, is already incorporating some search engines, as I showed before, translation, calendar, and other things. So this is basically the flow that you have. You get some questions, and then it will the output will be something like that, QA. In this case, the QA is the API, and then it will call this API to understand what is the what's Pittsburgh code, also known. So these are the idea. This is the idea. So ChatGPT also in the official web page, they cite some plugins. They mentioned that there are a lot of plugins. These are also tools. They mentioned that these are plugins that to help ChatGPT to access up-to-date information, run computations, or use third-party services. So there are a lot of plugins. Here I just give the example of Wolfram Alpha. So he can do some very complicated mathematical computation, like 3 to the power of 73, that I guess even a common calculator, I'm not sure it will be able to do, but Wolfram Alpha can do. And other things, like if you want to calculate distance in the Earth and different things. It also included a code interpreter. So if it can write a snippet code and give you run it and give you the result. I don't know if it's included in ChatGPT, because I tried a little bit and couldn't get the correct result for some simple things. But maybe you need to have the premium version. Maybe, I don't know. But you can also have a look at their official webpage to see the plugins. So this is a very interesting and comprehensive review of tool integration, also including systematic tests for zero and few shot prompts. It's based on these two form, but gives a bit more systematic way and tests with other tools. But it's basically the same kind of idea. Apart from this part, which is a bit different, it's called tool-oriented learning, and it says how to use some tools, like for instance, tweet love bits, and then it use the foundation model to call the API, and also run some other API to log into Twitter and create the tweet, for instance. So this is, I think, very. Can I have more time, because there was some at the beginning, there was some.
It's okay.
Yeah. So this is a very nice framework called LangChain. I was planning to go to the web page to show, because this is like I think the best direction to, if you want to do to use the APIs, open advanced APIs to our own products or things. This is the best place to go to. It shows a lot of examples of different APIs and different things to do. For instance, one example is to create a list in Spotify and suggest new songs to add according to a natural language description. So it gives all these examples, but there are like hundreds of examples in this framework, in this web page. It's for Python, but I mean, this is the best language, I think, to use. So another more advanced example using LangChain framework is this ChemCrow, augmenting large language models with chemistry tools. It includes some tools, some web search, literature search, molecule tools, and chemical reaction tools, some specialized tools to solve very complicated chemical problems. So ChatGPT 4 alone cannot produce like medical, drugs, for instance. Cannot give you any type of drugs suggestions or doing even simple chemical calculation. But using this tool in this kind of framework, they manage to improve incredibly the performance into some tests for chemistry. Consider it outperforms GPT a lot. It's a very nice example. So another example is Microsoft Copilot. It builds on GPT-4 and uses Microsoft Graph to convert user text into content Microsoft 365 apps such as Word, Excel, PowerPoint, Outlook, and Teams. It's still under test, but it will be released, I guess, and you can have a look there as well. This is we saw the YouTube. It's amazing. So you can do anything basically with just some simple prompt. The second class is writing codes. So as I said, there are already a lot of tools to writing code and testing codes. But you just suggest some block, some correct bugs and complete code, etc. But not giving a very complete code for advanced text that requires several models, dependency, interaction, etc. So the following tools that I will just briefly show, they kind of try to address that, at least first step, how to address that. This is called Neural Architecture Search. NAS is a proposal called Genius using GPT-4 to look for a neural architecture search. So this is the basically flow. So you start with a prompt saying, please suggest an architecture based on the following setting. So you can ask anything you want to get to identify image, for instance. Then GPT will give you some suggestion of architecture, and then you run the program, get an accuracy, and then you say, please provide accuracy as feedback to then you get a accuracy of the model, and then you say that you have an interactive prompt that goes back to GPT saying, this achieves this percent, please suggest a better one. And then it goes into a loop until it gets like an optimization. It's like a hyperparameter optimization using large language model. And they claim that they have improved over other methods into some, these are some image recognition tasks. But it could be, this kind of architecture could be used for other things. This is called Hugging GPT. Is also, I was impressed with some tasks that they mentioned, but it's very similar, but they didn't have GPT-4 yet. So they use only ChatGPT, but then they forage the Hugging Face. Hugging Face is like a lot of, they have a lot of models, machine learning models, and a lot of discussion by the community. So they use all this text and all the explanation of models to find what is the best model to implement some specific task. So it's a very, very interesting idea. And they managed to do some very complicated tasks. Like you say, for instance, I have this image, please find the position and then generate another image with a girl instead of a boy in the same position, but reading a book, something like completely crazy idea. And then this Hugging GPT finds all the tools necessary to do this task and call the model to do this task. I tried to download, but it's like 400 gigabytes to download the model. So I don't know how to get it, but I find it very interesting. So that was all the ideas that I went through. So I hope this gave you some idea of what's going on and have new ideas what we can do in the future. So just to conclude, so I'll summarize. So these large language models are powerful tools, but have some limitations. By integrating various tools, APIs, and libraries, they can get enhanced capabilities, becoming more versatile and powerful. And by fine-tuning and chain of thought techniques, it's possible to make them to learn the situation to use different tools. And they have also ability to write and run in code that can be incorporated into external frameworks for more structured and powerful programs. And some frameworks are available for this kind of integration. And I think this is the near future towards some artificial general intelligence. Thanks.
Thank you, Diogo. We have some time for some questions. Anyone who would like to ask some question, just write it down in the chat, or maybe you can ask directly. Just unmute, please, and do that. So I can maybe just start with a question. You showed like a table which was from the slide review LLM, where you have a number of different chat. Let me see. This one, yes. So you have a number of, let's say, other possible tools than ChatGPT, and they are much larger. So why do they not have the attention as GPT-4? Do you know? I mean, like Lambda, if you look at the Lambda here, and you have Glan, which is pretty big. Do we have an understanding why they are just less used, or are they used? But
I think the milestone that ChatGPT brought is this idea of having a chatbot, this conversation. It's optimized for conversation by using the human by reinforcement learning by human feedbacks. I'm not sure whether the other tools have also this capability of having this kind of very like human, like natural language conversation.
yeah,
But I'm not sure. I haven't looked in details in any of these.
yeah,
But it's something
yeah,
interesting.
because they are pretty much bigger. I mean, you have like yeah, the work. I mean, if you look at the size, and you were also in the pre-trained data scale, and you have, I mean, as an example, just Lambda is much bigger, or GLAM is pretty
No,
big.
Lambda has 137 billion weights.
I was thinking about maybe this
Maybe
12 JAMA or GLAM, or yes,
60.
yeah. Anyway, yeah. So there are, I mean, possible.
Pangu, I think, is the most powerful one. It's the most recent. I think this one is the Huawei one.
Okay,
It has 1,085,000 billion weight.
that's pretty big.
It's
Yeah,
1 trillion. 1 trillion.
yeah, 1 trillion. Yeah, yeah. Okay, another question is, you mentioned a little bit about the techniques that can be used, and I believe to be able to use the GPT full out, I mean, then you need to understand the techniques, how, as you mentioned, like how to do the prompt engineering, or the other thing like manipulation of the tools, etc., etc.
Mhm.
So that by itself is pretty advanced. What do you think?
Yes. You need to study in detail the prompt engineering, how to do it,
Yeah,
and fine tuning as well, how to add new data and how to add new information. So the idea of this in context learning is that you need to help the machine to know what you're expecting.
exactly. Yeah.
So you need to give some example,
Mm.
but it's the powerfulness of them is exactly that's the fact that the observation that even with few examples they manage to understand it and give you
Mm.
answers. But of course we need to go through more detail and try it to see what you can get depending on what we expect. If you want to some specialized like this chemistry, they also use engineering prompting to get what they need
Mm.
even before they go into the tools, because they need to know what kind of tool they want. So they look into the bibliography, a lot
Yeah.
of bibliography analysis.
Mm.
So you do really, in any case, even before you go into the tools, you need to know how to extract the information and how you will be able to call these APIs.
Very good. So the time is running out. So thank you very much, Diego, for this interesting, really review of the GPT and how to use it. So thank you everyone that have been joining here, and see you soon. Thank you. Take care.
Thank you.